Download this code from codegive.com, link in the description below. Secure remote access to your Homelab, a comprehensive guide. This tutorial focuses on enabling secure remote access to your Homelab without directly exposing it to the internet. Exposing your Homelab directly to the internet can open you up to security risks, including brute force attacks, data breaches, and malware infections. This guide will leverage techniques like VPNs, reverse proxies, and SSH tunneling to provide safe and controlled access. Understanding the risks of direct exposure *. Before diving into the solutions, let's understand the risks of directly exposing services like Plex, Home Assistant, or a web server to the internet without proper security measures. Brute force attacks. Attackers can try to guess usernames and passwords through automated attempts. Simple passwords are easily cracked. Vulnerabilities. Software often has vulnerabilities that can be exploited by attackers to gain unauthorized access. Exposing services directly increases the attack surface. Data breaches. If an attacker gains access, they could steal sensitive data stored on your Homelab devices. Malware infections. Compromised devices can be infected with malware, which can spread throughout your network. DDoS attacks. Even legitimate services can be overwhelmed by distributed denial of service, DDoS, attacks, making them inaccessible. 2. Secure remote access methods. We'll explore three main methods. 1. VPN, Virtual Private Network, creates a secure, encrypted tunnel between your remote device and your home network. This is the most recommended general approach. 2. Reverse proxy. Acts as an intermediary between the internet and your internal services, hiding their direct exposure and adding security layers. Suitable for specific services like web applications. 3. SSH tunneling. Port forwarding creates an encrypted tunnel through an SSH server, forwarding specific ports to your Homelab devices. Useful for occasional access to specific services. 3. VPN setup, recommended. A VPN is generally considered the most secure and flexible option for remote access. It encrypts all traffic between your remote device and your home network, essentially putting you on your home network. Choose a VPN server *. You have several options. Home router *. Some routers have built-in VPN server capabilities, example OpenVPN, L2TP/IPsec. Check your router's documentation. This is a convenient, if sometimes less customizable, option. Dedicated VPN server, example Raspberry Pi. Install a VPN server on a dedicated device like a Raspberry Pi. This offers more control and flexibility. Recommended for more advanced users. Cloud VPN server, example DigitalOcean, AWS EC2. Rent a virtual server in the cloud and configure it as a VPN server. This offers high reliability and performance but comes with a monthly cost. We'll focus on setting up OpenVPN on a Raspberry Pi due to its popularity and flexibility. Install OpenVPN on Raspberry Pi *. 1. Update and upgrade *. 2. Install OpenVPN and EasyRSA *. 3. Prepare EasyRSA *. 4. Initialize the PKI, public key infrastructure. 5. Build the certificate authority, CA. Enter a common name, example My Homelab CA. 6. Generate the server certificate and key *. Answer yes to signing the request. 7. Generate the Diffie-Hellman parameters *. 8. Generate the OpenVPN configuration file *. 9. Edit the OpenVPN configuration file *. Find and uncomment, remove the semicolon at the beginning, the following lines asterisk. These lines configure the VPN client to use the VPN as its default gateway and use Google's DNS servers. Asterisk adjust the proto line if necessary. Proto UDP is faster, but Proto TCP is more reliable. Choose based on your network conditions. UDP is generally preferred. Asterisk find the TLS auth line. If present, uncommented. If not present, skip this. Asterisk, optional, change the port, default 1194, if desired. This is a good security practice. E.g., port 44444. 10. Copy the necessary keys and certificates asterisk. If TLS auth is enabled, you will also need to generate a TLS auth key. And copy the ta.key file to /etc/open. 11. Configure IP forwarding asterisk. Asterisk uncomment the line asterisk. Asterisk save the file and run asterisk. 12. Configure firewall, UFW. 13. Masquerade traffic, NAT. Replace ETH0 with your Raspberry Pi's internet-facing interface, example OLAN 0 if using Wi-Fi. 14. Load IP tables rules at boot asterisk. Create a file to load the rules at startup. Asterisk add the following lines to the end of the file asterisk. 15. Enable and start OpenVPN asterisk. C. Create a client configuration asterisk. 1. Generate a client certificate and key asterisk. Replace client 1 with a meaningful name. Answer yes to signing the request. 2. Create the client configuration file, client1.open. 3. Copy the necessary files to the client configuration directory asterisk. 4. Create the client configuration directory, if it doesn't exist. 5. Package the client configuration asterisk. Replace client 1 with the client name you chose. 6. Transfer the client1.tar.gz file to your remote device securely, example using SCP or a secure file transfer protocol. 7. On your remote device, extract the client1.tar.gz file and install an OpenVPN client, example OpenVPN GUI, TunnelBlick, OpenVPN Connect. 8. Import the client1.open configuration file into your OpenVPN client. Note, you might need to manually add the CA certificate, client certificate, and key to the clients separately in some OpenVPN clients. D. Considerations asterisk. Asterisk dynamic IP address asterisk. If your home internet connection has a dynamic IP address, use a dynamic DNS service, example DuckDNS, no IP, to associate a host name with your IP address. Update the remote line in your client configuration file with the host name. Configure a dynamic DNS updater on your Raspberry Pi or router. Asterisk firewall rules on your router asterisk. Forward the OpenVPN port, example 1194 UDP, from your router to the Raspberry Pi's internal IP address. Asterisk security asterisk. Use strong passwords for the CA and client certificates. Regularly update OpenVPN. Asterisk testing asterisk. After setup, test the VPN connection from a remote network, example using your phone's mobile data. 4. Reverse proxy setup, for specific services. A reverse proxy sits in front of your internal services and forwards requests to them. It adds security by hiding the internal IP addresses and port numbers, and it can handle TLS/SSL encryption, rate limiting, and other security features. Nginx Proxy Manager is a popular and easy-to-use option for setting up a reverse proxy. Install Nginx Proxy Manager, Docker. Docker is the recommended way to install Nginx Proxy Manager. 1. Install Docker and Docker Compose asterisk. 2. Create a Docker Compose.yml file asterisk. 3. Create the data and let's encrypt directories *. 4. Start Inks Proxy Manager *. B. Configuring Inks Proxy Manager *. 1. Access the web interface *. Open a web browser and go to http://your_raspberry_pi_ip81. 2. Initial login *. Use the default credentials. *Email, admin@example.com. *Password, change. 3. Change the email address and password. 4. Add a proxy host *. Go to the hosts-proxy hosts section. Click Add Proxy Host. Domain names enter the domain name you want to use to access the service, example plex.yourdomain.com. You'll need to have a DNS record pointing this domain to your public IP address. Scheme select HTTP, assuming your internal service is using HTTP. If your internal service uses HTTPS, select HTTPS. *forward hostname /IP * enter the internal IP address of the device hosting the service, example 192.168.1.100. *forward port * enter the port number the service is listening on, example 324004 plex. *cache assets * enable this if you want Inks to cache static assets. *SSL * choose request a new SSL certificate using Let's Encrypt. This will automatically obtain a free SSL certificate for your domain. You need to ensure that port 80 and 443 are open and accessible to Let's Encrypt servers for verification. *save. See Firewall Rules *. Ensure that ports 80 and 443 are forwarded from your router to the Raspberry Pi's internal IP address. Important considerations *. DNS records * you must have a valid DNS record, or name record, pointing your domain name, example plex.yourdomain.com, to your public IP address. Security * regularly update Inks Proxy Manager. Use strong passwords. Domain name * you'll need to own or have access to a domain name. Let's Encrypt Let's Encrypt requires ports 80 and 443 to be open and publicly accessible to issue certificates. If you can't open these ports, you'll need to use a different method to obtain SSL certificates, example manual certificate creation. Internal HTTPS if your internal service uses HTTPS with a self-signed certificate, you might need to configure Inks Proxy Manager to trust the self-signed certificate. This is less secure than using a Let's Encrypt certificate on both the reverse proxy and the internal service. SSH tunneling, port forwarding. SSH tunneling creates an encrypted tunnel through an SSH server, example your Raspberry Pi, and forwards traffic on a specific port to your desired service. This is useful for occasional access to specific services but is not as secure or flexible as a VPN. Enable SSH on your Raspberry Pi *. 1. Enable SSH *. Go to Interface Options -SSH and enable it. 2. Change the default password *. Change the default password for the Pi user to a strong password. This is absolutely crucial. Consider disabling password authentication altogether and using SSH keys. 3. Recommended, disable password authentication and use SSH keys *. Generate an SSH key pair on your remote device. Accept the defaults or provide a custom file name and passphrase. Copy the public key, /ssh/id_rsa.pub, to your Raspberry Pi. Edit the SSH configuration file on your Raspberry Pi. Asterisk find the line password authentication yes and change it to password authentication no. Asterisk, optional, uncomment the line port 22 and change the port number to something non-standard, example 22222, for added security. Asterisk save the file and restart the SSH service. B create the SSH tunnel asterisk. On your remote device, use the following command to create an SSH tunnel. Asterisk local underscore port asterisk the port on your local device that will be used to access the service, example 8888. Choose an unused port. Asterisk internal underscore IP asterisk the internal IP address of the device hosting the service, example 192.168.1.100. Asterisk internal underscore port asterisk the port number the service is listening on, example 324004 plex. Asterisk user asterisk the username on your Raspberry Pi, example Pi. Asterisk your underscore public underscore IP asterisk your Raspberry Pi's public IP address. Asterisk N, do not execute a remote command. Asterisk F, run in the background. Example, accessing plex. C accessing the service asterisk. Open a web browser on your local device and go to http://localhost local underscore port, example http://localhost 8888. This will forward the request through the SSH tunnel to your Plex server. D considerations asterisk. Asterisk security asterisk using SSH keys is much more secure than password authentication. Always change the default password. Asterisk firewall asterisk forward the SSH port, default 22, but recommended to change it, from your router to the Raspberry Pi's internal IP address. Asterisk dynamic IP address asterisk use a dynamic DNS service if your public IP address changes. Asterisk multiple services asterisk you can create multiple SSH tunnels for different services by using different local ports. Asterisk automation asterisk use a script or tool to automatically create and manage SSH tunnels. 6. Securing your Homelab, general best practices. Regardless of the remote access method you choose, it's essential to secure your entire Homelab. Asterisk strong passwords asterisk use strong, unique passwords for all devices and services. Use a password manager. Asterisk two-factor authentication, 2FA enable 2FA whenever possible. Asterisk keep software updated asterisk regularly update all software on your devices, including the operating system, applications, and firmware. Asterisk firewall asterisk enable a firewall on all devices. Asterisk network segmentation, VLAN separate your Homelab network from your main home network using VLANs. This limits the impact if one network is compromised. This is an advanced topic. Asterisk intrusion detection / prevention system, IDS/IPS consider using an IDS/IPS to monitor your network for suspicious activity. This is more advanced. Asterisk regular backups asterisk backup your important data regularly. Asterisk monitoring and logging asterisk monitor your systems for errors and suspicious activity. Centralize logging to make analysis easier. Asterisk least privilege asterisk grant users only the necessary permissions. Avoid using the root account whenever possible. Asterisk disable unnecessary services asterisk disable or uninstall any services that you don't need. The fewer services running, the smaller the attack surface. Asterisk regular security audits asterisk periodically review your security configuration and practices. 7. Example Python script for automating SSH tunnel creation asterisk asterisk. This script simplifies creating and managing SSH tunnels using Python subprocess module. Remember to install the Paramyco library, pip install Paramyco. Explanation of the Python code asterisk. 1 SSH tunnel class asterisk. Asterisk encapsulates the information needed to create an SSH tunnel: local port, internal IP, internal port, username, public IP, SSH key path or password. Asterisk underscore underscore init underscore underscore initializes the SSH tunnel object. Asterisk starts the SSH tunnel using subprocess.popen. It constructs the SSH command based on whether you're using an SSH key or a password. It handles errors during the tunnel setup. Asterisk stop terminates the SSH tunnel process. 2 Error handling asterisk. Asterisk the script includes basic error handling to check if the SSH tunnel process started successfully and prints error messages to the console. Asterisk the try except block catches potential exceptions during tunnel creation. 3 Using SSH keys versus passwords asterisk. Asterisk the code prioritizes using SSH keys for authentication, as it's more secure. Asterisk if you don't provide an SSH key path, it allows you to use a password, but this is strongly discouraged unless SSH key authentication is not possible. Storing passwords directly in the script is a security risk. For example usage asterisk. Asterisk the if underscore underscore name underscore underscore equals underscore underscore main underscore underscore colon block provides an example of how to use the SSH tunnel class. Asterisk replace the placeholder values with your actual configuration. Asterisk it creates an SSH tunnel object, starts the tunnel, waits for user input, and then stops the tunnel. Security considerations for the Python script asterisk. Asterisk SSH keys asterisk always use SSH keys for authentication instead of passwords. Store your private key securely and restrict access to it. Asterisk password storage, avoid if possible if you must use a password. Do not store it directly in the script. Use environment variables or a secure configuration file to store the password and retrieve it at runtime. Asterisk input validation asterisk validate the input values, example IP addresses, port numbers, to prevent potential command injection vulnerabilities. Asterisk error handling asterisk implement more robust error handling to catch and log errors during tunnel creation and management. Asterisk logging asterisk log all SSH tunnel activity to help with debugging and security auditing. This script provides a basic framework for automating SSH tunnel creation. You can extend it to add features like automatic reconnection, port conflict detection, and more sophisticated error handling. 8. Conclusion asterisk asterisk. Securing remote access to your Homelab is crucial to protect your data and network. This guide has covered 3 main methods: VPNs, reverse proxies, and SSH tunneling. Each method has its own advantages and disadvantages, so choose the one that best suits your needs and technical expertise. A VPN is generally the most secure and flexible option. Remember to implement the general security best practices outlined in this guide to protect your entire Homelab from threats. Stay vigilant, keep your software updated, and regularly review your security configuration. By following these guidelines, you can enjoy the benefits of remote access while minimizing the risks.